And it's just a matter of putting it in parentheses, putting your text, and that that becomes your string value. So it's not code. It's just what I'm used to doing for string values.
So do any of those prior scripts use any Python or anything in an actual code block?
No. I try to do as much out of the box stuff as I can. Now, I do have a lot of packages that have Python in them, and I do provide a list of all the package libraries in the handout and also at the end of the presentation. But some of those do utilize Python. That the get work sets, that one's very Python heavy. I myself have a working knowledge of Python. I don't have a working knowledge of working with the API with Python. But I was kind of learning Python as I was doing this, which was really helpful, but not a requirement. You can do basically all of this stuff with out-of-the-box nodes. And the nice thing about it is that Dynamo's been around long enough that if you can't figure out how to do something with out-of-the-box nodes, chances are there's a package library out there that will do what you want to do. At least that's been my experience. All right, so that's the reference plane checker. The last example I want to look at, go back to the obligatory slideshow, the air terminal sizer. Now, for those of you that are not MEP people, ignore the fact that it says an air terminal. What this is really doing is going to illustrate how you can affect model change by a set of rules or design constraints. Okay. Now, admittedly, the functionality that we're going to look at with this can be achieved with if statements within a family. But this is much more user-friendly because I don't have to ask my users to go in and try to edit an if statement. They'll be able to just go in and put numbers in different locations and be able to affect that change. And we'll see that here in a second. Okay. So for starters, let's go to a floor plan view. And just kind of ignore all the weird stuff going on. This is my sandbox model. Is everybody able to read the tags? Because that's going to be kind of key here. You guys all see that? Okay. All right. As you can see here, okay, I have all of these air terminals with different flow values, but they're all 6-inch. Okay, that would never happen. So what we're going to do, we're going to run this script. It's going to go through, and it's going to automatically change all that stuff based on input from me that I put into the script. Okay. So when this runs, you will see the tag update, and just so you don't think I'm doing anything kind of weird, you'll see that family. It is a legit 6-inch 24 by 24. Okay. And again, I apologize for the downtime while it loads, but again, I wanted to give you guys a feel for how long it actually takes to load some of this stuff. All right, so I'm going to move it off to the side so you can actually see this happen. It's not going to be like this big dramatic thing, but you will see that these will update, the tags will update, so on and so forth. So I'm going to go ahead and click run. It's going to go through my project and it's going to change all those standards for me based on my design stuff. Sometimes it runs faster than others. Okay, so it's done. Right? Did everybody see that? It's hard to get excited about it, but it is awesome. Yeah, thank you. All right, so let's take a look at what happened here. If I go in and actually pick that family now, you can see that it actually did change the family. All right, and it went through and did that for all of these diffusers that I have here. You'll notice that I have aluminum and I have steel, okay? And it did that for all of those. All right. How did it do that? This one does look overwhelming, I'm sorry. First things first, and I will say this, by trial and error is the only way that I figured out how to do this. You would think that it would be really simple to just apply a value to the family type parameter, but there's a lot of formatting that goes into it, and it's usually family name and type that it wants the whole shebang, okay? So, rather than try to type all that stuff out, I just went ahead and first I used that family types selection method, right? And I put it through a process where by the end here, you can see I went ahead and got the family name and type. All right, this whole string value. And this is going to be true for whatever family you try to change. So from there, I got my parameter value. That's what that is. All right. You saw that I had two different types, aluminum and steel. So I went ahead and put it through a filtering process where I grabbed all those types and filtered it by steel, filtered it by aluminum, all right? And then I come up to this area, just ignore that for now. This one is still in beta testing as well, so it's not totally complete. But then I take it up to here, and that's where I'm splitting it out into those single family names and types, okay? Put it through a filtering process. I'm saying, look through that list to get all of the ones that are 6, 24 by 24. And this becomes my parameter value that I plug in. You'll notice that if I pan over the all ever important element number, okay? That's the actual, that's the brains behind it. That's how it knows what to actually change it to. Okay, so then I did that for each type. I just split them out into those single elements. All right, so I've got all my family names and types. From there, I need to actually get the elements that are steel and aluminum, right? And these are the actual elements in the model, not the database elements, but the actual elements in the model. So that's where this happens. Again, I'm putting it through a filtering process where I'm just grabbing those air terminals in the model that are steel. Okay? I got the same exact structure, same exact everything else down here, but for aluminum. Again, this is a great example of if you do it one way here and it works, it'll work the other way down here too. Okay? It's always consistent. All right. So from there, it goes through yet again another filtering process. Now, this is one of the things that I've learned that I've gone along. You got to tell it what phase to do this for, or else it's just going to do it for every phase that it finds in the project. Okay. So I put it through another filtering process. I just want you to look at and change the things that are on, in this case, new construction. Okay. Everybody with me? All right. So after all that, we have the elements in our model that are steel, that are on new construction. And from there, we're ready to go ahead and set those parameter values. But we do have to put it through one more kind of test, because in this example, not every air terminal is the same size given the flow, right? So this is where that design criteria, changing the model based on rules comes into play. And this is where it's much easier for a user to fill out this rather than a lengthy if statement within a family, right? At least my users. So, here's my range. Minimum flow, maximum flow. Now these are just code blocks that I renamed, okay? These are not actual names of nodes. I'll demonstrate real quick. You can right click, rename node, and you can actually give it a name. Okay? Makes it a little bit more easy to understand later on down the road. Okay? So I went ahead and I did that for all the sizes of air terminals. Okay? From there, we put it through a logic test. And basically this is just Dynamo asking the question of each element, hey, are you more than 0? In this example. Yes, I am more than 0. Great. You get to pass the test. Are you less than or equal to, in this instance, and these are all tied back to that specified value. So in this case, are you less than or equal to 150? Some of them are going to say yes. Some of them are going to say no. This is where that true false comes in. Yes, I am. No, I'm not. Yes, I am. So from there, we have that list of the yeses and the nos. It goes through, and now we have the elements that are left over, just the yeses of that steel type, of that family type. We can go ahead and finally, we've made it to the end where we get to specify the parameter value for that type parameter, which goes all the way back to our very first filter process back to here. Okay? So that's how it's doing what it's doing. Now, again, you can see when I was doing this, I didn't do all this all at once, right? I took it one chunk at a time. First, I had to figure out how to get the family type. So that's what I did. From there, I had to figure out how to split it up. So that's what I did. And you'll notice, again, those node structures are exactly the same. Okay? Just copy them, change some values, and you're good to go. I can't reiterate that enough. That is one of the greatest things about Dynamo and programming in general is it follows rules, and once you figure out the way to do it, you can apply that same logic if you're performing that same function, regardless of element. Okay? There. And I did condense that down quite a bit. So we have some time left over here. Well, actually, let's talk about the node packages here. Node packages that I frequently use to construct all of this great stuff. Arcolab.net, Blackbox, Bumblebee, Clockwork for Dynamo, Dynamo MEP, which is a fantastic one. Have any of you, how many MEP people are here? You guys like making spaces? What if you could make spaces based on the locations from the architectural model through the link? Wouldn't that be cool? We have some time to show you guys that. It's awesome. Dynaworks, which is it's an interface between Navisworks and Revit, where you can actually bring Clash data into Revit. Not everybody has to have managed to be able to actually look at the clashes. Lunchbox for Dynamo, Rhythm, Shive-Hattery MEP, that's mine. Spring nodes and steam nodes. I couldn't tell you what's in all of them. They all have a different set of stuff, but through the process of me trying to figure out how to do some of this stuff, along the way I find these, they have very specific things in them that have functions that I want, so that's how I ended up with all those. But they're great. I recommend that you guys check them out. Again, this is in the handout, so you don't have to memorize this list. Help resources. So we have dynamobim.org. That's the home for all things Dynamo. The great thing about Dynamo is that it is open source. Community is very, very helpful. I've never not gotten an answer to a question. Which brings me to my next one, the dynamobim.org/forums. That is the user community forum. Again, great community, a lot of helpful people. Never had a problem getting an answer to a question. 60secondrevit.blogspot.com. That's John Pearson's blog. He's the author of the Rhythm package. Very, very cool guy. A lot of just down-to-earth, straightforward approaches to using Dynamo. He's one of those that tries to do as much with out-of-the-box nodes as possible, because that's what we all have access to right out of the box. The revitcomplex.blogspot.com. That's Marcelo's blog. I don't know how to say his last name, which is weird.
Scabulary.
His last name is Meyerbock, though.
Scabulary.
There you go. I always joke that if it's not on there and you can't find it on there, you probably don't need to know. He's a really cool guy. If you have a chance to actually watch any of his presentations or attend any of them, I highly recommend it. He's very energetic, eye-pale in comparison. Then there's always Google, you know, when you need to go nuclear. That's a last ditch effort, but there's a lot of good information out there. Obviously YouTube is always a popular one as well. Okay, so I know I threw a lot of stuff at you guys, and it's the last day.